All right, so from last time, we got a transition matrix, P, and I said I'd do a video on the applications of how to go about using a transition matrix. So to use a transition matrix, you're going to do is, what you're going to need is something we call a coordinate vector, okay? And the operation that you work with is you take the matrix P and you multiply it by a coordinate vector. In our case, our matrix P went from, it was a transition matrix from, and let me write this out real quick, from B to B prime, okay? And what that transition matrix does is that it takes the coordinate vector, we call that, and I'll go into what that is in a second, from in B, which is like this, you multiply by P, and it gives you what this is right here, okay? And a little diagram here is in blue. Okay, but first of all, what do we mean by a coordinate vector? So a coordinate vector is a vector in Rn, okay? So it's R1, R2, R3. And the way you form a coordinate vector is as follows. If you're given of any vector u, and you write it out as a linear combination of vectors which form a basis. So in our case, let's say v1 vn are basis vectors for some vector space, and let's say we call that set B that contains all those basis vectors. Then the coordinate vector is basically just the coefficients that are form the linear combination. That's what that is. Okay, so to expand on this, if I gave you the vector 5 plus 7x plus 11x squared, and I gave you this basis for P2, which was just the standard basis 1xx squared, then 5 plus 7x plus 11x squared can be written out as 5 times 1 plus 7 times x plus 11 times x squared. And that coordinate vector u, which we write like that, ub, would be equal to 5, 7, 11. Okay. Now how you write this out, you can write it out as a row or a column vector. However, when you do work with these operations in terms of multiplying by the transition matrix, you will use this as a column, okay? All right, so that's what we mean by a coordinate vector. And what basically the transition matrix does is that if you know the coordinate vector of a basis for a given vector u, when you multiply that vector by p, it tells you what the coordinate vector would be in another basis for that same vector space, so b prime. So let's go with this example, and I'm grabbing the same basis that I used in the last video. So b is 1, comma 3x, comma x squared minus 1, and b prime is 5 minus x, 1 plus x squared, comma 7. And your transition matrix is that. And again, that's the transition matrix from b to b prime. And here's the question. Given u is 1 plus 9 plus 5x squared, find ub prime. And here's what I'm going to add with the transition matrix. Now, you can't do this problem without using the transition matrix. And I'll get into a little more detail on that in a second. So here's how you go about doing this problem with the transition matrix. The first thing you're going to need to know is you're going to take that vector u, which is 1 plus 9 plus 5x squared, and you need to know how to write this out as a linear combination of the basis vectors in from B, okay? So the basis vectors of B were 1, going back up here, 1, 3x, and x squared minus 1, okay? So how do I go about doing this? Well, it's you can do it a couple ways, trial and error, or you can set up a system of equations. Now, what I mean by trial and error is as follows. Like if I have 1 plus 9x plus 5x squared, how would I write this out as a combination with the basis vectors of 1, 3x and x squared minus 1 here. Well, if I say to myself, for example, 9 here is 9x, excuse me, is how can I get this from what I have over here? Well, the only thing that contains an x is this part right here, so that C2 would have to be 3, because 3 times 3x would give you 9x. And I need to have a 5x squared, but the only way I'm getting an x squared is from that, so I'd have to have a 5. And if you did the math with that 5 times x squared minus 1, you would get 5x squared minus 5. And I would need to add how much to get 1 up here? Well, that's 6, okay? So that's how I could get those numbers. But of course, some people don't feel really all that comfortable with this. So what you can do here is you can set up from this setup that I have over here, this a system of equations. It's a linear combination. And yeah, all I'm saying here is I'm trying to rewrite 1 plus 9x plus 5x squared as a combination of 1, 3x, and x squared minus 1. And if you were to do the quote-unquote math here, C1 minus C3 plus 3C2 plus C3 x squared, you would have a system of equations here. C1 minus C3 would have to give you 1. 3C2 would have to give you 9. And then C3 would have to give you 5. Okay. So solving this would give you C1, C2, C3, which is the 6, the 3, and the 5. Okay. So, either way works. So our coordinate vector then would be for right over here, let me denote that, would be 6, 3, 5. Okay. So the way this is going to work is you're going to take your coordinate vector 6, 3, 5 and just multiply it by the transition matrix. Okay. And when you do that, and I'll let you take care of that right there, you get negative 9, 5, and 41 over 7. So the coordinate vector for you in B prime, this other basis, is minus 5, 41 over 7. Okay. And, sorry, that is a little sloppy. And basically what this means is that you can rewrite 1 plus 9x plus 5x squared as minus 9 times the first vector in B prime, 5 minus x, plus 5 times the second vector, 1 plus x squared, plus 41 over 7 times 7, 7 being the last vector here. And yeah, that would, all of you were to do the math, that works out here, okay? So that's how that's applied. Now, as I said earlier, you could figure out this value, the negative 9, 41 over 7, sorry, negative 9, 5, and 41 over 7, doing this directly by setting them a system of equations with B prime instead. So basically you would do the same thing that I did like up here, but instead of where I have 1, 3x, and x squared minus 1, I would have 5 minus x, 1 plus x squared, and what's my last vector here? 7, excuse me, for what you have at these places right here. Okay, so so you could do it directly. So there's a couple ways of doing that. Okay, so just be aware. However, most of the time they'll ask you to apply the matrix and go from there. All right. Well, thank you for your time.